As you might notice, I am not from here. This is actually the first class I've ever taught in the USA. And so if you don't understand, if I'm using words that you don't use, I'm basically a recent immigrant. So please, if you don't understand my accent or you don't understand things that I'm saying, just wave at me. It's impossible to offend me. Like, I'm happy to be interrupted at any point for any reason. So please do, if you have any questions, you know, do feel free to ask me. Let me tell you a little bit about what I want to do with you over the course of the next couple of hours. And then I'll introduce some of my work and then we can get started on making. So the thing that I like to do a lot is so I'm a hardware hacker, which means that I make things using microcontrollers and electricity and sensors and robots and all the things that, all the parts of technology that exist in real life. That's my bag, right? The thing that I really love doing is doing that with materials that are unusual, okay? So using architectural materials to create circuits, or using fabric or paper, these things, these soft three-dimensional things that you wouldn't necessarily associate with hardware, with electronics, but you can do some great things. So today, we're going to go over the very basic building blocks for making electronics. I'm going to teach you how to make a circuit, and there's not going to be any science involved. I'll probably pepper in some fun science facts about it along the way, but we're not here to learn theory, we are here to learn how to make things with electricity. So it's going to be very, very practical. You can ask me questions if you're curious about how stuff works. I can't guarantee I'll always ask them. I don't have a college degree in electronics. This is just how I've taught myself how to make all of these things and kind of create all the stuff that I create. So we're going to start off by learning how to make circuits using paper, and then we're going to go into how to use E-Textiles, so the basic concepts of working with fabric and electronics. And by the end of today, you will have made your very first circuits in a number of different circuits, but you'll also have made your first wearable. So we're going to be, this is assuming none of you are already, not already experts in wearables and just here to show me up. But we're going to make a bracelet that lights up when you wear it, but it will also be able to use it to test whether different materials in your environment are conductive or not, with some surprising results. So that's what we're going to do today. But before I dive into the practical bit, let me do a little bit of, I'll just explain a bit can I show my slides, please? Thank you. The glove on the front is the glove that I designed for, if any of you know the musician, maybe she's too British, but there's a musician called Imogen Heap, and I designed that for her. She's like famous in the UK, but I don't know if she's famous yet. Okay, so slide one. This is what I'm talking about when I'm talking about enchanted technology. I'm not going to wander around. Sorry, people at home who are watching, I'm a wanderer. I'll try and stay in one place. I like to stroll around the classroom when I'm teaching, but today I'll stay put. All right, so this is one of my early makes from when I started, because I didn't study technology. I came to it through a series of communal spaces in the UK called maker spaces, which are essentially shared working spaces where the machines are shared and you share the knowledge as well. So I learned everything I know about electronics, about robotics, about all these kinds of things through maker spaces, through hacker spaces, through my friends teaching me, and through YouTube. So, you know, I'd like to point that out because I think with electronics, a lot of people think it's like for engineers only, but it's absolutely not. It used to be like 20 years ago, but now it's just really, really accessible. You don't have to know a lot of the theory in order to make some incredible creations. So don't be scared of electronics. This is one of my, this is a creature I made. I made a series of these. These are gesture-controlled robot unicorns. And what they do is, I mean, they're just stupid robots. They just drive around. And I used to race them. Like I had a herd of them, and I would take them around different museums, and people would race them. And instead of racing them by pressing buttons, I coded it so that you had something in your hand that you shook it like the reins of a horse to make it go forward. And then you turned it, and you turned it by going this way or this way, and then to slow it down, you had to go, whoa! And like, and on purpose, I made the wheels kind of wonky, and I made the way that we control the wonky wheels like very inefficient, right? So they had the mind of their own. They didn't do what they were supposed to do. And as a result, these stupid little robots were and still to this day, one of the most popular stupid robots I've ever made in my life, because people like imperfect technology. The reason this is my first slide is imperfect is good. It gives personality, it imbues life and warmth to something that if it just went straight forward and straight back and it had a perfect case made of metal, nobody would be interested in it. You know, so imperfect technology made by people who don't know anything about tech. At this point, I didn't even know how to code text code. I did this all in block code with children's microcontrollers and crocodile clips. So imperfect technology with imagination is so much greater than perfect technology with zero imagination and like just straightforwardness. So the reason that's up there is not because it's good, but rather the opposite. Okay, we're going to create enchanting, imperfect, fun, imaginative technology in these 2 weeks, and it doesn't necessarily matter if it's perfect. So there we are, robots. Now let's see what on earth slide I put next, because I can't. Okay, so yes, I'm introducing myself. Here we are. So I am a writer. I've written a number of books, 8 books to be precise. This is a still from the Crafty Kids Guide to DIY Electronics, which was my first book in my own name. And it teaches kind of what we're teaching today, really. So it's how to make circuits using unusual craft materials and skills. And this was written for children. I actually wrote it with an advisory board of 150 girls who chose every single project in this book, because it was really important to me to have an electronics book that was female coded and for the needs of young women. So that was that. I've also written for everyone, but whatever. This is something that's quite relevant to here. This is a project that I designed for you'll see this on the logo actually, you'll see it around. This is a product I designed for an artist in the UK called Imogen Heap. It's a children's version of an adult glove, which is a MIDI controller that you, instead of pressing buttons or kind of twiddling knobs, you control music using gesture. So by moving your hands around, by doing certain things. And this is the children's version of it that kids can, like, they wire it, they code it, they play it themselves. But this has been used by loads and loads of musicians as well. And I'll give you some examples of that, not today, but on the coding day. So like I'm teaching today, and I'm also going to teach the Introduction to Coding Day, which will be next Monday. And by the end of next Monday, you will be able to make a gesture-controlled musical instrument. I promise you. Like, there's no way that you're not going to be able to do it. Probably by the end of the first hour, you'll have made one. So that's kind of what we're going to do. This is another one of my, I'm not going to give you a whole like artist talk, but this is just another example of technology being repurposed. So something that I like to do in my own work is collaborate with lots of different people, because I think if you bring your skills to the table and your friend brings your skills to the table and you smush those skills together, you're always going to get something that's bigger than the sum of your parts. So this is you'll notice it's a robot unicorn again. But this is a robot unicorn that was made by a leather artist in London. Not like a leather artist. She does like very fancy gloves for royalty and so on. So she saw my robot unicorns while I was racing them, really loved them, and said, I'd love to do a collaboration. So we made a full leather, I didn't bring it with me, but I'll bring it next Monday. A full leather glove that I use to then control my robots like I'm an evil overlord. Forward! But it's really fun. But eventually I took the unicorn out of, I stopped using it, and I ended up just using the glove. And so now that glove is actually a cello synthesizer that I've made, and all the code for this is up on GitHub. It's actually reasonably easy. I will show you how to do this again next Monday when we do block coding. And it controls the sounds with gesture. It controls the sounds of different recordings. I've recorded a bunch of different machine shop sounds, and also my friend is an artist who bounces sounds off of the moon and then records them when they come back. So it also controls like a moon bounce cello as well. So the reason I put that up there is to show you the kind of weird, so like my vast majority of the stuff that I make for my own person is I make musical instruments. That's what I do. And this is an example of like just how one project has gone from like silly robot all the way down to a product, then followed by like actual like musical instruments with collaborations with artists. So my point really here is silly things like this can actually end up being quite impactful. So this led to this and led to that. So, you know, free creative technology is very exciting. So that's just a sample of what I do. This is just another, I won't play this, but this is one of my instruments. I made this series of circuit sculptures. This is actually a sub-bass that you play, but we're not going to play it today. So that's me, kind of. I make weird instruments and creative technology. I was a working artist in Berlin for the last 3 years, and before that I was in London doing hacker stuff. I've recently moved to Portland, hello, for work. But yeah, I make strange instruments and so on. We're going to move on to our first part of today. And here's the only tiny, teeny-weeniest bit of theory that I'm going to tell you. You do not need to know, for this stage, you don't need to know how to make calculations for power balances, you don't need to know all of this, but you do need to know a few practical things about working with electricity. So let's see what we're doing here. Here we are. So yeah, is it possible to take my, oh no, I guess that's fine, don't worry. Never mind, it's fine. So a circuit, so humans make all sorts of interesting things with technology, right? So from things on space stations to lights in here, we're using all sorts of things in our lives that harness the power of electricity. Electricity, you know, we're relying on it for so much. All a circuit needs, so a circuit is basically one complete piece of electronics, okay? So like one set of things that does a thing, right? It can be all sorts of different things. And there's 3 essential components to any circuit. One is the power source, here represented by this large white component. This is like a little sleeve for a 3-volt battery, which is the little coin cell batteries that you get. So that 3-volt battery has 3 volts of electricity inside of it, and you push it in there. And so that's our power source here. And then the other component at the top, this is our thing that does something, right? This is our output. This is what we call an LED, which is a light-emitting diode. And when you push electricity through components, so we've got that electricity in our battery, and then we're pushing it through components like an obstacle course, right? And it does things over every obstacle that you push it through. Okay, so that's, in this case, an LED. When you push electricity through it, you get light. But there's other things you can do. You can push electricity through something and you can get movement. You can push electricity through something and you can get sensor data. So all we're doing really is taking power, and that power should be aligned with the component that you're using, but we'll get onto that in a bit. You don't have to worry about that for now. So you take the power and you push it through your component, and that component does something because of the power. The other part you need in a circuit is the path, okay? So the power needs a path to be able to travel along. So in this case, we've got our battery down here, and then you can see the battery has a positive and a minus sign on it. Now the positive sign is the positive side of the battery, and the negative sign is the negative side of the battery. I know, it's rocket science, right? And what you do is this is using some silver thread that I've embroidered here. So what it's done is I've used my thread to connect the positive side of the battery to the positive side of the LED. And then I've cut it, so there's no connection. And then I've taken my thread on a slightly windier path, but it still does the same thing, from the negative side of the LED to the negative side of the battery. And as long as you do that, it should work. Okay, so we've got a 3-volt battery, we've got path to the LED, we push it round. Now some components, it matters which way round you put them, LEDs being one of them. Some components, it doesn't matter. Okay, so you can have like, for example, a vibration motor, like what you'd feel in pretty much anything, well, you know, anything that vibrates has got a vibration motor inside of it. A vibration motor doesn't matter which way around you put it, but for LEDs it does matter. So always watch out. If there's a positive and negative sign on your component, it probably means it matters. So that's the basic thing. So that's what we need: power, component, and a complete path. Now, in practical terms, there are 3 things that you're going to need to watch out for when you're first starting to create a circuit. What is a short circuit? So a short circuit is on this path here. So we've got a path going from negative to the negative little triangle, which is this space for an LED. And then you've got the positive going to the positive side, right? Okay. Now, if there was a line connecting the positive and negative side without going through the component, that's a short circuit. And that means the component wouldn't work. Why? Because electricity is lazy. It will always take the path of least resistance. So if you give it away to go through it without having to go jump over the obstacle of the LED, it's going to be like, see ya. We're not going to light anything up. So electricity is lazy, so watch out for those short circuits. They're number one. So they're like a really big problem when you start out, especially when sewing. Just keep an eye on it and you'll be fine. Loose connections, also a big thing. So like if it's not making contact properly, that's probably, that might be another reason. And the LED orientation, as I said before, LEDs have to go match up with the battery, okay? Those are the 3 things that you're probably going to bump into on your first few projects. Watch out for your short circuits, make sure things are connected nice and properly, and make sure your LEDs the other way around. The other thing that it could possibly be, if your circuits aren't working, is the power. So the vast majority of, if your battery's not working, sometimes batteries die, sometimes batteries are rubbish. So if you don't have any short circuits, if your connections are good and your LEDs are right around, try switching out your battery. That's it. That's all you've got to really watch out for here. When you go further on, you will also need to watch out for power balancing. So components need a certain amount of power, and batteries have a certain amount of power. You need to make sure that those 2 things marry up with each other, and we do that using something called Ohm's law. But we're not going to do that today because we're just doing practical stuff. So this is going to be our first circuit. I am going to stop talking for a hot minute, and I'm going to show you on this down. I'm not going to stop talking. I'm going to show you on this down camera, if that's okay, how to work with thread. So if you open up your boxes, open up your kits, you'll find something that looks like a roll of sellotape. Like this, okay? And that's important. You're also going to find your 3-volt batteries. It's a little coin cell battery that looks like this. And then LEDs. Do not have any plain LEDs. That's okay, we can use the little sequin. Kat, do we not have any ordinary LEDs?
I can grab them.
I like that. So I'd rather use the sequins for the sewing, if that's possible. So, while we get this, oh, that's fine. I'm going to draw this here. So we're also going to need a piece of paper, because we're going to make our first circuit now. You get a piece of paper and a pen as well, just to sketch it out before. So the previous place we just saw, so we're going to, let me just remove this, so it's clearer. So I'm going to fold down one corner of my paper. This is going to be where the battery goes, okay? because we need our circuit to make contact with both the positive and the negative side of the battery. And the way to do that is to fold over the piece of paper.
Does anyone need a pen or something to write?
And I'm going to come around table to table and help you out on this as well. So don't worry if you don't understand this first time. It can be confusing the first time you do it. Okay, so if we open up our battery, you'll see that's where that's going to go, okay, like that. So we've got our power source, we've got our LEDs that are on the way, and this sellotape looking stuff, is it the sellotape brand name here, or are you all like, what's sellotape? All right, what's the equivalent?
Like
Scotch tape, there we are, it looks like skinny Scotch tape. All right, weird. So there's a, so there's a plastic wrapper on the outside of your Scotch tape, and you'll find on the inside, if you have a little look at it, it's got one side that's silver, and then there's the white sticky back on it as well. So what this is conductive tape. This is what we're going to use as our thread, as our wiring, right? So in a normal electronic circuit, you might use wire. You've got, or is it just...
these are the only LEDs, the neopixel ones.
Oh, okay, I can use the sequins then. That's fine.
Yeah, I couldn't find any anywhere.
That's fine. Okay. That's fine. All right, well, if you get this red bag as well, it says Adafruit LED sequins on the back. And I think they've got a 3-volt forward voltage, so we should be okay. So if you just I should have just done it on the camera. So it looks like this, and then what you do is you break the 2 black bars off, like that, and then you're left with 5, what we call sequins, LED sequins. These are teeny weeny little sequins, okay? Those are going to be our lights, so just choose one of those, and we're going to put the rest of them back. Don't lose those because you need them for the bracelet later. So here we have that. Right, has everybody managed to get all of their components? Yeah? Okay, cool. So we've got this tape, and when you peel it off, if she can peel it off, she cannot. I'm so bad at getting the edges of tape. So we're going to use this tape to create the. Can you switch back to the slides? This. Okay, so this is the path that you're going to create, right? So essentially, you see that corner bit that I want. That's the bit that I folded over. So I would recommend you draw out your path. Draw out this path on your piece of paper, like this, and then leave a gap for where the LED will go, and then go up like this, like that. Okay. So if you want it like this, okay. So here's my example of that. All right. So I've got a fold here, then I've got a path. Because what I want it to do is I want the bottom of the LED, the bottom of the battery to connect with one of the parts of the line, and then the top of the battery to connect when that folds over, right? So that doesn't. Oh yeah, I'm going to have to do that. So that's what you want to follow, like that kind of thing. I mean, you can do a more interesting path than that if you like, but this is just, because it's your first one. So essentially, you can see when I fold that over, that top bit of that line is going to connect with the top bit of the battery, right? One side of the battery. And then the other bit is going to connect underneath. All right, so once you've got that set up, and then this is the space that you leave for your sequins. Now remember, as I said before, electricity is lazy, okay? So if you put your tape or your line underneath your electricity will go through the path, not through the LED. So you need to leave a gap. So you can see there's a gap here for where my LED is, because you need to force that electricity to go over that line. So then, when you've done your path, get your conductive tape. So there's a couple of different things that you can use for paper circuits. So the most common thing that you find, is copper tape. And that's used, you can buy that in hardware stores as like slug repellent as well. So it's exactly the same stuff, it's super cheap, it's really fun to use. This is just made of fabric, it's a bit more expensive, and it has the glue, the adhesive on the other side, is also conductive. So it makes it a bit more friendly for beginners, right? But you can also just use slug tape that you get at the hardware store. All right, so the way to work with this stuff is you peel off the backing a few centimeters, an inch at a time. Imperial. I know it's our fault, but it's stupid. So you peel off a couple of centimeters here, you'll see this, and you can see that it's tape, right? And then you just start peeling it, you lay it down, peel it, just put it down like that. And then when you get to the corner, this is where you have, so pay attention for the corner bit, I'll show you a couple of times. Right, if you want to turn, so I want to go down this way. So in order to go down this way neatly, what I do is I pull the whole tape the opposite direction, like this, and push it down. Okay, so then I've got a little right angle here that's going in the opposite direction to where I want it to do. And then once it's gone pushed down, you push it back again, so it makes a little neat fold, like that. Comme ça. And now I need some scissors. There are scissors hanging around. So that's how to make a little right angle turn. And you can make all sorts of different turns with that technique, just by pulling it the opposite direction you want to go. So then we have a path. I'm going to just do that again. Just here, just so you can see. So I'm going down a path. Let's trim this off. So you go down the path, you go the opposite direction, and then you go the real direction, making a little corner fold. Again, opposite direction, pull it back over, corner fold. It's worth trying that a few times, just to get the hang of it. Because you can also, you can do some really intricate turns. Just take a little bit of practice. And the reason I bought this tape instead of copper tape is because it is a bit more forgiving. So if you are not that great with your hands and you're having trouble doing that like neat turn, you can also just kind of like, smush it around a bit like that. That'll still work. Okay? Like, so it's, if you want to be messy, you can go on ahead and do that. Yeah, and smush it around. So this is, it's just got a bit more robustness to it. We all good? Right, okay, so then we're leaving this gap, remember, so that we make sure that the electricity isn't lazy. And then we're gonna, let's actually tidy that up. Then we're gonna do the same thing on the other side, remember to leave that nice gap for the LED. Here we have E. There we go. Yeah. I'm doing a very messy corner here. It's been a minute since I've done a paper circuit, to be honest. Yeah, there we go. There's some really great tutorials on this online, and I will make sure that I pass those around as well for like future learning. So here we go. So there is that's my path there. So I've got my path from this side of the battery. Just check that would connect. It would connect, so I'm just checking that the top should touch the top of your battery, and it should not touch any other part of your circuit, okay, because that would cause a short circuit. All right, let's see if this LED sequin works. Okay, good, that works. And those of you who've already made your path, I think thing you can probably figure out, if you take your LED sequins, you'll see that part of the little tiny sequin here, part of it is gold, and part of it is black. And the black is not conductive, so it won't conduct the electricity. So you need to touch the gold parts to your conductive, to either side of your conductive path. And then you need to complete your circuit. Let's see if that, so there we are. So it does that, okay? You can probably, so it needs to remember, if you look at your coin cell battery, you've got one side that's smooth with writing on it. It's got a little plus, right? That means it's positive. The other side of your little battery has got bumps on it. That's the negative side. And if you look at your tiny LED sequin, you'll also see a positive and a negative side on it. Now remember, electricity is lazy, so make sure that it goes on the path correctly, and also that your connection is good. You might need to push down on it to start with. And remember that the LED needs to go the correct way around. So the positive of the battery needs to be linked to the positive of the LED and vice versa. I just turned that wrong way around. Right. We made it. You got it? Is anyone having trouble? I can come over and help you. You all good. You've managed to make it work. That's great. You all good? That's fine, don't worry. How's it going? Looking good? Yeah? It's looking good. This might be a bit close. See when that's, it might potentially, if you're bending this over like this, you can see it like that. Just touch it to make sure that it's not touching. Yeah, even on the edge. Yeah. So I take a little bit of that off. So that when it falls over down, all right. So that's your sequin 1. So that you've completed now. I think almost everybody here has managed to make their first LED. If you've managed to make your first LED light up, can you put your hand up? Line. All right. Is anyone still working on their first LED? All right. I'll come over and chat. So those of you that are already made your first LED, so I'll come around and help everybody in a second, but I want to move everybody else on to the next thing. So for those of you who have made your first LED lighter, you might be wondering how to make more than one LED lighter in the same circuit. Now there are 2 different ways that you can make more than one LEDs light up, and it depends on how you lay out your circuit. The first way of doing it is in a series circuit, and a series circuit is what is like what I call like a daisy chain, right? So you'd go, here's your battery, right? And then you've got one LED. This is the LED symbol, and then another. So this is positive. This is positive. Positive. So this is exactly the same as this circuit, right? Except instead of one break, you've got 2 breaks. Okay, you've got 2 breaks and 2 LEDs, right? And so because this is 2 LEDs and it's done in a series circuit, like a daisy chain circuit, you need double the amount of power. Okay, so 2 LEDs means 2 batteries. And in this instance, you want to have, in this you can just stack 2 batteries on top of each other to make a series circuit lighter. So why don't, those of you who've already managed to to make their first circuit, why don't you start having a go and making a circuit that has space for 2 LEDs in series, like this. So it would look like that, gap, that. Okay, so you've got 2 gaps and then the battery. I'm not a very good drawer, sorry. Yeah, you've already had one battery, you've got more batteries, but you can also just check your circuit works with the battery next to you. Okay, then. So hopefully everybody has made, there are a bunch of these, different paths to follow. So we've just done the very basics. We've done a series circuit with the 2 batteries stacked, and we've done the simple circuit, which is the first one that we've all done. There are other types of ways of lighting up multiple LEDs, which is a parallel circuit, which we're going to do in a minute. We're going to sew our first parallel circuit, but you've done a simple circuit now, and you've now done a series circuit, which is the daisy chaining. So remember, when you're daisy chaining your components, you also need to bump up your power, okay? And when you get into that, that's when you need to start looking at Ohm's law. We don't have to do that today, though. What I will do is send around all of my slides, and there's loads of notes in here as well. So if anybody's, we've got to move on from paper now to sewables. But if anybody wants to continue doing a paper circuitry, there's all sorts of really interesting resources. The number 1 resource that I would look at, there's a woman called Ji Kui, and she runs a little tiny company called Chibitronics. Actually, it's worth me just showing you. Let me see if I can bring it up. The light only works when you push it because there's not a secure connection, because we're just...
No, I got it to work.
Oh, yeah. So, can you take this out? Why is this stream thing here? That's not me. It's the CETI. The program. Okay, so I'm going to have to move on from paper circuits now. I only had time to do a very, very quick rundown, but this is like a really good starting place for going further with paper circuits. You can make all sorts of interesting things. There's also, there's a couple of copies of my book around on the tables, and there are lots more. The whole first chapter is about paper circuits. So if you're interested in that, they're around to have a look at. But also look at Chibitronics. She does some incredible things with paper circuits, including pop-up books and all these really incredible things. So she's definitely the paper circuits queen. So just definitely look at it. And I will share a link to this in the things. Now, where's
We'll also just put it on the Discord channel too.
Yeah, sure. Oh man, I hate doing this. Here we are. There we go. All right, so moving on, it's now the top of the hour. How did that happen so quickly? I don't know. We're moving on to E-Textiles, which is one of my favorite types of materials to work with. So can you put the slides on? That's it. I'm just going to talk you through what's on here. So this is an example of some of the different types of conductive materials that you can get. E-Textiles and Conductive Fabrics are something that we're seeing so much growth in this field at the moment. It's a very exciting field to be part of. So some of the things we have here, we've got some woven conductive fabric. So these all function in the same way as your wires, right? So think of conductive fabric as a way to create your own sensors or create your own parts, or to create your own inputs. So we have some stuff here that says like woolen yarn that you can felt with or you can weave with. You've got, down in the right-hand corner there, you've got conductive Velcro, which is actually incredibly useful for wearables because it means that you can rip on and off your electronic components, right? Which means that you can wash your stuff, okay? So one of the really good use cases for E-Textiles is body interfaces that you can take off your electronics from and wash it. I'll give you more tips about that over the coming, but yeah, this is just an example of some of the types of things. So you can do threads, you can do fabrics, you can do like, you've got some kind of like interesting kind of like bark, like cloth kind of stuff. There's lots of really, really interesting things that you can experiment with here. My absolute go-to place, there's basically the Bible for wearables. It's this German, it's not even a company, it's a German studio called Kobakant, and that's K-O-B-A-K-A-N-T. Honestly, it is a very ugly website with everything you could possibly want to know about DIY e-textiles. It will be, if you are going into this, it will become your Bible. It's made by two women called Hannah and Mika who run a studio in Berlin, but they met at MIT, and they've done all sorts of really, really interesting experimental things, and thankfully have documented all of their stuff. So that is the first port of call, and I will share that because it's amazing. You should definitely look at that. There's also a whole bunch of books around this. So obviously, like mine does the basic stuff, just for how to work with the threads. But one of my favorites, and that's actually a free download as well, is by one of the speakers next week. There's a woman called Sophie Wong, and she's a designer who also does a lot of wearables. And she's got a whole book of beginner-friendly wearable tutorials that is available for free because of Raspberry Pi funded it. And that's called, Sophie Wong Wearables. Just download that book for free, have a look through it, would recommend. And then the Kobakant website. But yeah, it's a very exciting field. You can use it for all sorts of things. I've made like machine learning yoga pants with some of these stretching things. So basically, it can tell like what position you're in by how much you're stretching, and then it like meows if you're getting it right, which I never am. I'm terrible at yoga, really bad, and not very bendy. So this is what we're going to make today. This is a wearables project, very, very easy. It's a very, one of the most essential tools for any electronics hacker is a tool called a multimeter. And a multimeter can measure some interesting things about your circuit, but the most useful thing about a multimeter when you are starting out is a thing called a continuity tester. And a continuity tester essentially just finds out if something is connected or not. Right? So you're trying to find out if the electricity is flowing from one point to another. And you can use it, I use it a lot to find out if materials are conductive. Like when I've taught electronics, I've sent my students out into a supermarket with a multimeter and told me to bring back anything conductive that they can find. For example, fruit is conductive, like anything with high water content is conductive. So they go out, they find these conductive things, and you can just basically figure out what's conductive in your landscape or not, and that helps open up what materials you can use in your own designs. So we're going to make a continuity tester wristband now, which we've got 55 minutes. All right, that's interesting. Right, I've brought lots of nice colour felt. If everybody wants to come, so there should be. This should be enough for 3 wristbands each. And I've got pink, purple, teal, or black. If anybody wants some of these, well, you will. Shall I just pass them out? Let's just do that. What is one for sale? You want pink? Is this okay? Okay. But again, you can't have the whole thing to I don't have enough sufficient ability. Do you want a second colour? I mean, it's half of it, whatever fits around your, it's got to fit around your wrist, right? So, yeah, cut it lengthwise, so it goes around your wrist. Big mark. So what you want to do is you want to cut it lengthways. I would say no less than 2 inches, but you can go further if you want a thick one. So just cut it lengthways down to whatever width you want your bracelet to be. So like a long strip, it should be able to fit around your wrist, okay? Like so. Okay? They can be thinner than that. You know, just whatever width wristband you want to wear. Let me cut one.
I would have brought all my stuff, but they didn't want to bring it.
Can we go to the slides? Because I want to show the circuit. So that's the materials you need for this one, sorry. So as well as your fabric, you'll also need your sequins, the little LEDs that we were using earlier, so you need those. And you'll also need some little snaps. You've got some, I don't know what you call these in America, like press studs, whatever. What do you call it? Snaps. These. Do you need some of these? Your fabric, you need some press studs, you need your conductive thread, which is on a spool like so. You will also need your needles, and you'll also need ordinary thread as well. So just your ordinary cotton. I do have, for those of you who like a nicer colour, I do have some lovely bright coloured embroidery floss. Yeah, this is the last stage, so I'll just keep it up here. So we've got nice matching embroidery floss when we get to that. Okay, so that's those. I'm actually going to go this. So this is the circuit that we're going to be making. Okay. This is a parallel circuit, which means, so remember when we did the series circuit, we were connecting end to end like a daisy chain. So in a parallel circuit, we're just using one battery, but what we're doing is we're connecting all of the positives together and all of the negatives together, and that's a parallel circuit. That means it only needs one battery, but it's going to use the power in that battery more quickly, right? So it's just going to eat your power a little quicker, but it's only 3 LEDs, so you should be fine. So this is the picture of the circuit that we're going to do. So what I'd like you to do is take your thingy and lay it out. Where is my battery holder? Here it is.
Should we make it like the size or?
Yeah, make it the size of your wrist. So basically, what we're going to do is you make it whatever size your wrist is, because there's going to be a wrist cuff, and it's going to snap together using the fabric snaps. So because I've got quite small wrists, I need to cut a little bit off here. So it should go round your wrist with maybe like an extra inch to spare, so that you've got enough room to sew in your battery, to sew in your snaps, right? Like so. Oh, this way, here we are, like that. So you've got this piece of thing. Slow this out. Ooh. There we go. So on your coin cell battery, again, you'll notice that there's a positive side and a negative side. So remember, we're going to put all the positive sides of the LEDs. I want you to all, so we're going to use 3. I'm going to line them up. It might be worth, can we switch back to the slides? It might be worth you sketching.
Yeah.
Why don't you copy this, sketch out this onto a piece of paper first? Huh? It's also on page 24 of 144 of the book, if there are books on the table, is this picture of the circuit. So here we have, I'm going to point out the thing. So you've got here, this is the positive side of the battery, and we're going to sew from the positive side of the battery with our conductive thread. So all positive sides here, so it's one long line, this is all connected. And then on the negative sides, we're connecting all the negative LED lights sides together, and we're going to attach that to a snap. And on the other side, this snap attaches to the negative side of the battery, so that when you close the snap, i.e. you put it on, it completes the circuit. Okay? And that's how we're going to use it as a continuity tester as well. Is we're going to use 2 snaps. We can touch this snap and this snap to something else to see if it's conductive. And if the LEDs light up, it means that it's conductive. So just, it goes inside your battery holder. Okay? So just sketch that down before you start with, don't start sewing yet, just make sure, just get familiar with the fact that we're going to connect. You can lay out your pieces. Can we switch, can we have a second down? No. So I'm just going to show you how I'm going to lay out my pieces. Yeah, we're going to put the coin cell inside the battery holder.
The coin cells that we have in the kit are double with the coin cells.
Oh no.
Are they the wrong size?
Yeah.
Do you want to trade blue for lavender?
Well, we can go and get. Christ.
Do you like blue better than lavender?
Well, you can always just put. We can make it work. We just push the bits down, and it'll still connect. It's still 3 volts. It's fine. We'll cross that bridge when we come to it. All right.
Okay, so which ones you keep?
Hang on. Where are my snaps? Here they are.
This one? Okay.
So they go like that.
And then
Like that. All right. So can you show my desk? So I've not sewed anything yet, but you can see I've got, here we are, we have 3 LEDs laid out here. So this is where my positive, this is where the positive side of my battery pack is, and that will connect to all the positive sides of my LEDs, and then the negative side of the battery pack we're going to connect to this snap, and then all of these LEDs, the negative side, we're going to connect to each other and then to this snap. Okay, so that's what that looks like. So if you all lay them out so that you can see that you have all your parts ready, then I will teach you how to sew with conductive thread. Okay, so what we want to do is not this. The battery will come with a little header pin, some little lines. Just ignore those at the back of the box. We're not going to use those today. We're going to sew them. We're not going to solder them. Right now, this is what holds your battery. Okay, so.
Yeah, that's what they do.
Yeah. Yeah. So this side we go.
is technically small, but still.
Is this the battery? Go the other way.
Yeah. I mean, basically, we should have one slightly larger one. They're still the same.
You would go like waffle size up?
So positive goes to the positive. So there's a positive sign on the top.
Okay.
Yeah, so flip it over.
So the negative, so this is the positive.
Exactly.
Okay.
That's correct. Yeah.
And then it goes. I have so many tools, I don't know everything. Okay. And then,
All right.
we're using these all these.
So I think everybody has got their thing. You've got your components. Yeah. All right. I feel like we're at a stage where I can show you how to work with the thread. So we've got our basic circuit. Does anybody need any more time to lay out their components, or can I tell you how to sew? I feel like.
Just like 1 more minute.
Okay, I'll give you 1 more minute. Absolutely. Thank you. Right, let's get my stuff together.
The middle side on which side?
It doesn't matter, but I like it.
Yeah?
Close it to on. So I'm thinking about how I put it on my wrist, right in the middle. At least two big holes.
And I don't know why, but it was probably just on the middle side. That's what I was trying to get. So I like the I didn't like the microphone because it was straight from the
All right. All right. So shall I show you how to sew? So, yeah? Okay, so even if you already know how to sew, it's worth paying attention because there's a couple of unique things that you need to pay attention with this. So essentially, so what we've got here is we've got this fairly stiff thread, okay? It's fairly stiff and fairly thick. There's all sorts of different types of conductive thread. You can get stuff that you can use in embroidery machines, you can now. You didn't used to. You can use this kind of stuff in the bottom thread of a sewing machine as well, not in the top thread. It will destroy your machine. But we're going to use it today for hand sewing, okay? And hand sewing is a really nice thing. There's a couple of things to watch out for. So when you get your thread, I tend to double thread it so it's double strong. It's not only just double strong, but it can also carry double the amount of current. Okay, so however thick your wire is. So if you've got like something that needs a lot of electricity, you'll notice that it's got a bigger, thicker wire, right? So, I mean, it's fine for LEDs, but if you're doing something more heavy duty in the future, you probably might want to consider doubling up or even using a kind of like a wearable friendly wire. The best kinds of wearable friendly wire is something called silicon wire, and it's coated in a really nice feeling and very flexible silicon coating, so it works really nicely. But I'll come back onto that. So I've double threaded my needle. I'm just going to tie a knot as per usual. The thing to watch with these types of threads is you can see, I don't know if you can see, but like it doesn't knot quite as nicely, so like it can come loose. So the number one thing to watch out for in when you're sewing with conductive thread is it doesn't behave like ordinary thread, in that sometimes the knots come loose. And sometimes, not in this one, sometimes the thread is quite furry. You know, like the fibers come out, right? And you can't really see it unless you look real close. But when you look real close, the fibers are coming out. And if you're sewing something and you don't want to have a short circuit, you need to watch out for those fibers, because those little hairs, they can expand and then they can touch the next path over, and then suddenly you're like, why isn't this working? And it's because it is a microscopic bit of conductive fluff is causing a short circuit. So I've got two very practical ways of assuring that doesn't happen. Number one, if you're using a fluffy thread, I put a bit of a spritz of hairspray on it after it's done, and it tends to keep it in place. I put a little spritz of hairspray and then smooth the hairs down, and that tends to stop short circuits if I'm doing fine work. And the other thing is, with this type of thread, the type of thread you've got, you can, if you've knotted it already, you can see it doesn't, it wants to come unknotted. It's like, it doesn't like it. So what I'll do is I will put one tiny drop of clear nail varnish onto the knot, and that will keep it in place and seal it. Okay, so I will always at the end of the day seal it. This is the thing. Can we go? Can you go back to this? So this is the other thing you need to really watch out for. Remember I was saying short circuits and loose connections are usually why things don't work. So when you are sewing components, when you're sewing your sequins on, if your connections are not tight and secure, like these, you can see at the top of in this, the top one is securely fastened. You've got 3 or 4 stitches securing the component to the fabric. And on the second one, it's not very well secured. And the second one, it doesn't work. Okay, so you want to make sure that the component is nicely stitched down before you tie off. And then the other thing you need to watch out for are loose ends, short circuits, okay? So when you've tied your knot, you'll see that there's a whole bunch of stuff hanging off. If this is underneath where you can sometimes forget it's hanging around, and it will create a short circuit. So make sure that your components are on securely, and that your stitches, your underneathing is nice and tidy. So you can like cut off the tails, once you're done, cut off the tails, secure them with nail varnish or a drop of glue, just to make sure that your wearables aren't going to destroy themselves for just being a bit messy. So, I mean, aside from...
Sorry, you said tight, and then what was the other one?
So you make sure that they're tight, and make sure that there's no loose ends hanging around that can cause a short circuit.
Okay.
Okay, so like, you know, when you're tying off your thread, you've got the 2 tails, right? Just make sure those are trimmed.
Okay.
Yeah, so just make sure you're not accidentally doing a short circuit. And aside from that, it's just like ordinary sewing, okay? It's just slightly thicker thread. So what we're going to do, if we're doing this, let's start off by securing, I'm going to start off by securing my, my battery pack in place, okay? So if you look at your battery pack, you've got some holes on the edge which are used for sewing, or you can use them for standoffs or whatever, and there's all sorts of things. We're going to use them for sewing. So you'll see there's like some tiny weeny little holes here, which we don't need to use. We're just going to attach to, let's just make sure that I'm not lying and that this is actually connected, because I don't want you to make you, I can't see the traces. Oh no, those are used for standoffs. Switch on. All right, so what we want to do is we're going to, it says on, right? We've got an on and a ground and a ground. So the ground is our negative. So what we're going to do is we're going to take our conductive thread, push it up through our fabric, and then I'm going to attach through the little tiny hole for ground. She says, have I used the wrong size needle? No, I'm okay. No, I have used the wrong size needle. Huh. Okay, so don't use the biggest needle. I've just discovered it won't go through.
So are we not sewing it down with the big corner circles?
No, I've just had a little look at it, and it's not the type that I thought it was. So we're going to have to use the
tiny dots.
Yeah, the
Okay.
tiny ones. So we're going to use a smaller. Do you know what? I've literally just done exactly the same thing. What is wrong with me? Okay, let's just get one of my needles out. Just rethread it. Make sure it goes through. All right. So make sure your needle goes through your. Huh? Yeah, so we're going to attach ground. That's exactly right. We're attaching ground to the circuit.
The needle doesn't fit in this big thread.
We're going to have to use a smaller... What do you mean the needle doesn't fit in there?
I figured out which one to use. I didn't use this one on this right one, okay?
Okay.
Yeah, choose the medium-sized needle for the...
You're doing great.
You're doing great, yeah, we're just learning.
All right. Whew, it is hot. Okey-doke. So here we have the ground. So once you've got it through the ground, just whip it round the edge of the circuit board, like, and back through the thread. Essentially, we're just securing and then go back up through the hole. I'll show you in a sec. Just I'll do a couple more. You can fit it through a couple of times.
Did we go through ground or on?
Go through, well, it depends whether you're doing the ground line or the power line. But yeah, we'll do the ground first. So go through ground. That's the negative.
So, it doesn't matter which ground.
It doesn't matter which ground, you're connected.
Oh, we found that. I was like,
So what you do is go over here.
Thank you.
So for this, what we're doing is you pop it down on here, and then you bring it up from the underneath like this.
Okay.
And then you put it round. So basically, you pull it up like this. So you can use the housing on the inside. And then we're going to push it through again. All like this.
She's looking to do it on the same bit. Do they pull out some of the wheels? Like with the big person's hands, when you put it in the middle.
Big young eyes. So yes, basically push it through, and then you secure it around the edge of the circuit board. This is why sewing electronics people love insulated edges.
You go up.
Exactly. So I'm just wiping it around.
When you're done, then you come back again.
I'm just going to show you. So we've got that.
Oh, you go the opposite way around.
That's fine.
Doesn't matter.
Oh, no, this is perfect. Yeah. Would you show other people like as well? That's great. Yeah. Just so you can see. So that's great. Nice.
If you go to the other side of that one, you just sew from this, so the cap, always go to the negative part. And on that, go inside or down, so it's start. Does anybody else need to see it?
Wow, that's like So here we have, so the reason I had you do the ground one first is because it's all you have to do is connect the ground one, you sew it to the snap. Alright? Snap one, okay? You can do it in whatever order you like, but I've just done the ground to the first snap, and then the on one you want to do to the positive. Yeah.
So it's not very conductive again.
that's it, that first one.
Oh, that's what.
Huh?
You don't know like
I would go like twice, just to make sure it's nice and secure.
Okay. There's only one, right?
there's 2 holes for ground, and that was the negative.
There's 2 holes for ground, 1 hole for on.
I'm blind, so I can't see it without somebody cleaning it up.
It's kind of a weird silk screen, like, normally we're like 3 holes for ground, I'm like, on.
So we don't need on, or we do need on?
Yeah, so 1 is ground here, so power is, so ground goes to that snap. Okay, so that's what we'll do. So you can make the hole. Yeah. Huh?
So you have to remove the other ground one?
Absolutely, you can cut off yours, but off.
Look at that girl.
So that's just right.
Layers, okay, on and in.
She was the one that was where they. Okay, so there's ground in.
So basically, when you use your arm switch on to go around it, just to make sure it's not.
No.
Crossing.
Question?
Different, like crossover.
So probably moving from the way.
Yeah, in my position.
Yeah, so it was the training. Or ground, she did the whole thing.
Yeah, so you can go
I
around.
did it back.
So I know it's not first.
I do not snap it, so you have it.
But if I go up.
This is not, I go back to where I think it's on.
Yeah, so you make the connection.
So it's just like.
So
So once it goes.
I asked her to not have that.
I'm doing very much because I've been very short. Okay, so we have now. Don't worry if it's confusing. It's always confusing until it works. And you don't have to understand it's literally your first sewable project. You know, we're just going to muddle our way through it. We're learning the skills. We're learning what you have to do. Doesn't matter if you're not immediately an expert in it, okay?
And now that we slightly sew to the end to one of the snap ends.
Yeah, so the first thing is literally just round, all I'm doing is cutting some round snap. It doesn't make enough so that all of you can do it. Like, you can do it. So that's connected to round. And so that you have to do, so you connect it round to round.
Or no?
When I look at this, it looks like the circuit all goes to this, but like.
Yep.
That's like that.
So do I go back?
We go, this is the end of this here, right? Tight, okay.
And then
I'll let you start it again when you do your second round.
You have to start it.
Backwards on accident, but yeah, you're gonna go around, and then one of the snaps, okay. Okay, so then you started a new round. Sorry. I'm not sure.
Opposite way round. So
Okay, sorry, I have a question now.
yeah, that's fine. It's okay that you've done it the opposite way around by connecting. So basically, a lot of you have done negatives. That's fine. Do you know what? I'm just going to redraw that so you can all use that. That's fine.
When you get to the part where you're sewing your
All right. So we've done battery. We've got. What do they call it? They called it on. Ridiculous. So this is the ground and that's the on. So everybody I think has done the opposite way around. So that's fine. So we want the ground to connect to negative, 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 right? and then the final snap. So I think quite a lot of you have done this, right? So you've connected the ground to three of the three negatives, and then the snap. That's totally fine. You just need to invert. What you need to do with the on, then, is from the on, you just connect the on to a snap. Okay, just only connect the on to a snap. And then this, you do, these are positive. Then we're going to connect the positives this way and to the snap. Okay? So that's
So I put, you want me to, so from here, you're going to go around here, and then I'm kind of,
when you come to the end of any circuit, any path, you need to cut the thread. Do not continue along, because that the electricity will short circuit itself. Okay.
so I'll cut that, and then
Cut that.
and then we're ready.
Okay, so then you start with the on.
So just
You connect all the top, all the on or switch. I think both of them are on or
Do I
switch.
sew both of them?
You can sew either of them. So I think switch must be, yeah. So if you're sewing the on part, I've not used this particular component before, but by having a look at it, I think on is always on, and switch is, you can use the switch to turn it on.
Okay.
So the SW, which is the one is the thing at the top, and that's your power. Okay, that's your positive. So that's your that's the other part of your circuit.
So I start that switch, and then I start sewing this.
Yeah, so the switch will go down, 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 positive, positive, positive.
Okay, so I have the positive on this side.
Exactly.
Okay.
Yeah, exactly.
Can I ask a question? This pointer I have.
So you're on ground.
That's on this one. those are the two places I looked. Yeah. I'm thinking while I'm talking.
Second round on the ball. Yeah, that was the second switch. But also you
Switch
switch.
would be positive.
Yeah,
So on the
switch.
nine, would be positive.
I have a question.
Okay, so you're just connecting. Yeah.
So we see some of the ground on the same thread at the same time. So I did yeah, and then, but now
I haven't even finished mine. So, just cut this. I should have
Do you
done
say you're teaching something else later?
on Monday. I'm doing coding.
We'll be there.
All right.
We'll
See
see
you
you. Thank
later.
you so much.
You're welcome. All right, I'm going to try and do one quickly. Can you put the circuit back up? The slide, sorry. Yeah. What's that? So we got switched or on.
It's drawing for you. Wow. You can make like different designs in the top too. It will draw the.
As long as you put it in the proper format. Yeah.
Is that what you're gonna do?
I'm not really not, but ink space.
Yes, and then it's my again, oh, dear Lord. Yeah. That's all right. It's like, I'm just, I was going too careful on it. Okay, but only thing I need to know is how to tell which my eyes can't see, which one's positive and negative.
I'm just doing one I made earlier, just so we can all see what's going on.
So, the size of it is visible.
Okay, and it goes on this side, I start.
Right? Yeah, of course. And just very quickly make it happen. You can come along.
So it's gonna
So, like, maybe we're gonna go snap first.
Yeah.
How do we transition from like that to the like positive?
and then the next question is after that.
That goes like that. No, that's this one. So this is a new piece, right? So this is a new. So you've created it.
Should I cut the thread?
So yeah, at the moment this is short circuited together. So the ground should not be attached to the arm.
On the positive side.
So if you because that's because if you allow the electricity over from arm to ground, so where did you get to? So you connected. Yes, you need to connect the ground, only the ground to the snap.
But I
Thank you.
Oh, yeah.
We're about to.
okay, so do all the positive side.
Yep, all positive.
I got it. I'm just gonna do the positive side all the way down and then I'll have to go to that. Facing that.
I've come to a little bit of an issue. I just realized that these are on the same side. They're not going to be able to snap together. Yeah. We could always just do that. That also works. You know. I made it a little big, so that's at least there's that. Oh.
Yeah, that's true.
And for this one, what do I sew on with?
Or you can just sew another one on. And that's just decorative. We're meant to do that. We're meant to do that.
That way you can't really see.
Yeah.
So with this one, do you just sew this one on with regular thread, or?
Yeah.
I'm correct in thinking that the corners are just for attaching, right?
Exactly. Yeah, no, unfortunately not. I thought they were. So some of them there are. I thought that's what they were, but that's not what they are.
Because we want this thread to be a little clear.
That's my third sequin gone.
Are you going to teach your kids this?
I teach at a.
Brown's over here.
Oh.
Brown,
And I
red.
teach
exactly correct. And this is just going from switch, correct? And that's not attached to anything else, just switch. And this is just attached to ground.
Right.
Alright, so then you want to do, yeah, exactly, so just turn it off. Then you want to connect these three together, conductive thread.
Oh, I do?
Yep, so we want to connect the three grains.
With nothing else? Just only the 3 ends?
3 ends, and they go to a snap here.
Okay. And they will,
And that snap will connect to this one.
okay, so this is grounding, and then sew it all the way down, and then a snap, then it should connect. Perfect. And then with regular thread, sew these 4 ends.
Yeah.
Okay.
You've got it. You've got it.
And then I just looped it, and then I just so go up and then
It's just to have the use.
yeah, and then go switch the house on here.
You don't have to.
Yeah, that's my jam. I've never done anything with technology.
If you want to do it the way that you're teaching it, you can have you can tie off here, and then when you snap it together.
Amazing.
Yeah, that kid seems so bad, man. He's like all the
So, okay, so.
Thank you. Your hair's so nice.
You would have to make a disconnect.
Yeah, because I went from bleaching my hair to nothing but hair for like a year. And COVID started shaving my head. And then I grew my hair out. And I was probably used to be unicorns. I was like, oh, good. That's what I want to happen. I know, I want to do that to my hair. Yes, because it's split. If I had my school kit back from home, I would have done the bring it, and then I would have been like, oh, we're sewing, because I sew with embroidery, carpet thread, all kinds of stuff. It's thread that can't break, because everything I make is, it's exactly like this, I wonder if it's connected, but it, this is not one, right?
This is kind of
Yeah, okay. So embroidery or embroidery is really thin, but it's really thick like this. So it's multiple threads. Yeah, that's great. Well, I want to keep on trying this.
So that's what I should be. In terms of the battery, reduce down, so I can hold it in there.
That's such a neat little tool.
That's going to work today. I'm going to incorporate your everything that I use in my field.
I wouldn't want
Alright, let's figure it out. So, trace it back. So right now we have switch.
An alternative to what? An alternative to
Yeah, but what I learned was like, oh, my art career took off because of art to do. Because I want to so social, that sometimes it hinders my practice, so now I'm at the workflow and I'm working with it. So it's like, okay, these are my work hours.
But you might be right, because it was what's happening when
I really wanted to do this on my What we started
Well, we can get her
Yeah, there's actually this website. You just go to the website. The only thing you have to get is the it doesn't have private. So you can get you have to be on So the best part is which one is very useful. You can just use it as a card. And we're just for the has on the screen and you just throw that here and then you kind of like check the other page for sure. It's really good. That's definitely unfortunate. We did actually, I think I didn't do it all. They're not the best, but there are some things that there's also
Did you repeat
All right, so everybody is either done or very close to being done. For those of you that are not done, if you want a little bit of extra help, I'm going to be sticking around and troubleshooting for the next little while. But before we wrap up for this morning's session, I wanted to talk to you a little bit about glove packing. So gloves are one of the more popular things that people do when they're starting out with wearables. It's quite you can do all sorts of things, from secret signals on your gloves to controlling other things. And we're going to do some of that. But the easiest thing I'm going to show you how to do, so touchscreen gloves. It's really, really easy to make any glove that you own into a touchscreen glove using just the materials that you use today. It's really, really simple. So the touchscreen gloves use something called capacitive touch. So it knows where your finger is, right? It can sense the disturbance and the force. And to make any touchscreen glove any ordinary glove into a touchscreen glove, all you have to do is take the thread that you have used today, and you don't have to sew any components onto it or anything. All you're doing is you're sewing a pad through the fingertip of your glove, with that thread, so a little pressure pad essentially, and that will transfer the capacitive touch essentially from your fingers through the glove, no matter what material it is, into the phone. So you can hack any glove into a touchscreen glove just by using a few little stitches in the finger of your glove. So I did want to show you that. But I also wanted to show you a couple of these glove things. And as I said at the beginning of the session, this is a musical glove that I used to gesture control a synthesizer that I made, which sounds very complex, but honestly, this is done using maybe 20 lines of code and some block code. So we're going to, on Monday next week, we'll be showing you how to create a gesture-controlled musical glove that you can put on your hand. But that's the other thing. So gloves there's lots of interesting things you can do with gloves. So we'll do that next week. All right, that is the end of the session. What we've done today is we have learned how to use paper circuits. We've learned how to make our first circuits. A simple circuit, series circuit, and now a parallel circuit. So you have created today all three of the major types of beginner of circuits, right? So you've done the series, and the parallel, and the simple. We've worked with LEDs and different power, and we've also worked with paper circuits materials, and also E-Textiles as well. So this was meant to be a very quick tour of the kind of things that you can make electronics with alternative materials. But I would encourage you to use the bracelet that you've just made yourself to go out and test things in the world to see if they conduct electricity or not. And you can use that as a way of deciding on fun things that you can make with your electronics. So, yes.
So my question is, if the bracelet's on when you're wearing it, if you touch something that's conductive, it turns off?
No. So the way it works is if you take your bracelet off, you'll know that the snaps are not connected, right? You can use those two snaps to touch any material, and then if your bracelet lights up, then that means the material that you touch is conductive. Okay, so you can do it with metal or anything juicy, usually. Yeah.
So I need to remove.
All right. So there is lunch. Did you want to say anything? Okay. I'll be around for questions and so on in a minute.